Thank you. All right, so let's start from here. So with regards to this talk, by the way, this is true. This talk was written mostly when I was sleep deprived or in between planes or on the plane. So I will be racing through different topics. So whenever you have a question, don't hold it up till the end because you'll forget what your question was about. So just stop me, ask the question, and we'll continue from there because there are going to be a number of topics. What this talk is about is how do you leave the cutting edge when you use technologies that are new, not even proved yet, when you're developing something for a market that is just starting being formed, just like Bitcoin market, and there's a lot of uncertainty in that as well. How do you combine that to your own benefit, and how do you get most out of it? So what's our story? Our story was pretty simple. We were a small but passionate Erlang developers team, and we had various open source and proprietary consulting projects, and we also tried to develop a couple of products on the way as well. They did not work out as well as we expected them to, but that was all right. And then we had a look at Elixir about 2 years ago. It was 0.5. And it was pretty far from what it is today, but it was quite interesting anyway. So we tried it out on a couple of projects, both, again, open source and proprietary, and we really liked it. So after that, what happened about a year ago is the Bitcoin spring of 2013, when everything just happened. The Bitcoin, again, skyrocketed, crashed after that, and there was so much interest in happening in that market, and we reached out to some people that were interested about Bitcoin, and apparently there were thousands of people who wanted to get into this market. So we suggested that our company, Bex.io, will be a provider for all repeatable parts of the business model of a Bitcoin exchange, and let our partners deal with regulatory, marketing, and banking relationship aspects of that business. And obviously, by being an Erlang and Elixir team, we obviously decided to continue in Elixir and see what we can get done with it. So why does Bitcoin matter at all? Why is it something that we need to be familiar with even if we don't use it? It's a very interesting innovation and experiment in how you can leverage the internet to create truly untamperable, massively replicated databases. In this case, it's a ledger that nobody can modify, nobody can double spend, and it's enforced by the network. It removes the middleman, so there's no need for central parties such as banks to allow you to send money from point A to point B, and you don't need to trust them. It's all the laws of mathematics and cryptography that it really enables it. It enables mistrusting parties to actually agree on the same truth, which is, in this case, the application is the money application. So we need to be sure that the money we receive is actually legitimate, it's not fake, and somebody is not trying to double spend that money. It's one of the simplest and most important applications of trust. And if we would think about what it also brings to the table, it's the digital age programmable money. So the money that you don't just hand over or receive, or you have to have some enforcement available to do more complicated contracts. It actually allows you to program certain contracts that are absolutely enforceable technically, and there's no way to get around them or cheat. So that's a really important technology that is being developed right in front of our eyes, and there's a lot of interest in happening in that market. But obviously, every new technology comes with its own dangers or things that you need to be cautious about. So one is, it's often deemed to be a benefit of Bitcoin. It's the irreversibility of transactions, which means once the transaction is sent, well, you can say goodbye to that money. There's no way to do a chargeback like with your credit card, so there's just no way of getting it back. On the other hand, this is really great for merchants that always sustain this loss of chargebacks, claiming that was a fraudulent transaction, and every business that accepts credit cards, they lose a certain percentage of their revenue by having to do chargebacks with their credit card company. The other really important aspect of it that comes out of irreversibility is theft. Since it's digital money and since it's stored as, it's basically private keys that somebody can get a hold of. There are many ways to steal this money. So that somebody can get a hold of your private keys or figure out a flaw in your software that will allow to drain your, for example, cold storage. And cold storage is an air-gapped storage for Bitcoin. So it doesn't allow a hacker to go directly into the cold storage, but it can trick your system that prepares transactions for the cold storage to drain unauthorized withdrawals from the cold storage, sort of a vault of your Bitcoin. So there's a lot of theft-related issues. Also, complexity. In order to really understand Bitcoin, especially from the engineering perspective, it's not enough to just read even just the white paper that was originally written about Bitcoin. You really have to spend some time going through all the documents available on one of the Bitcoin wikis, read some source code from Bitcoin, etc., to really understand all the important intricate details of Bitcoin itself. And Bitcoin API, even though it's pretty good, it does a lot of things, it's still not where it probably should be with respect to writing new kinds of services that are based on Bitcoin, especially with regards to being able to proactively monitor the network and see what's happening on the network without pulling the server all the time, which obviously creates a certain number of problems. So what do we do about that? Our architecture is actually pretty simple. We have a standard Bitcoin D node looking into the outside world that sort of proxies the entire communication with the network to us. So we can be sure that every message that came to us is already validated by the reference implementation of Bitcoin. So it's cryptographically validated, and there's nothing wrong with transactions that are coming at us. Because every Bitcoin server will not propagate a message that is invalid or malformed. It will just stop it right there. And then what we did, we created our own Bitcoin protocol implementation. It was all created in Elixir, and it was a great learning experience, and it does allow us to do really interesting things with it. It allows us to see everything as it's happening immediately and have a very deep look into every transaction, every block, every event that is happening on the network. So we can know when, for example, we're receiving money into the system without, again, pulling the server. But on the other hand, and it's a big aspect, the complexity of doing work that happens after parsing the protocol is actually quite significant. Just to give an example, to implement the Bitcoin protocol implementation, it took about one night, like 6 p.m. to 10 a.m. kind of thing. So by 10 a.m. it actually worked. But to get the confirmation counting and analyzing blocks of transactions, it took us about 4 months to get it more or less right. And we still know there's a lot more work to be done to actually make it even better than it is today. So it's an important aspect to understand. And there's obviously good and bad sides to both approaches, whether you implement this protocol parser yourself or you just completely rely on third-party software such as Bitcoin D. I think ultimately what will happen in this market is there's going to be more libraries that allow you to not to re-implement it every time you create something. And we're actually working on Elixir library that encapsulates all the Bitcoin functionality just in one single well-designed library. It's not open source yet because it's not ready, but sometime later this year we'll release this library, and obviously the Erlang and Elixir communities will be able to play with Bitcoin natively out of Erlang or Elixir. Moving further, so in our products, our first product that we're releasing to the market, it's actually more of a market maker product. It just allows you to go and simply buy or sell Bitcoins with the site operator. So it's not enabling you to trade Bitcoins and other currencies with other users. We didn't deploy that functionality for primarily business reasons, but we did two interesting experimental implementations of the order book. Is there anybody here who does know the term order book? Okay, order book is basically, you can see that as a table where all the buys and sells or bids and asks are in the table. So if you want to buy a certain amount of Bitcoins at a certain price or a certain limited price, you just put that order into the system, and somebody wants to sell Bitcoins, they also put an order into the system. So that forms an order book where you have offers and people who want to buy certain quantities on certain conditions. So the order book, the order book engine, what it does, it matches those orders and sees where is the best match, and basically does the exchange transaction between those users. And if there's any residual order left, so if your order wasn't, like, if we wouldn't be able to close your order in full, there's a way to leave a residual order so that the next counter-matching order will come up and we'll be able to complete the entire order. Does that make sense? Good. So we did two implementations, and they were quite interesting, actually, just to see what we can do with Erlang and Elixir, to that matter. So the first one, a simpler one, was a linear implementation. Basically, it was two tables, order set ETS tables, obviously all in memory, no disk involved at all, just to make it faster. So two tables with bids and asks, and every time a new order comes in, it's basically matched against existing orders in the counter table. So if it's a bid coming in, they were matching against asks and vice versa. And if we find something, we take off a part of the incoming order and make an actual transaction. And whatever is left by the end, by the end of traversing the table, it's a residual order that we put on the book and wait until next order comes in. So our preliminary results were that in about 2 minutes or so, we can process about 300,000 orders of that kind, and it was about 200 lines of code. So worked pretty well. It was interesting. Then we tried a parallel implementation, which is still to this date is a little bit more experimental. It requires, obviously, because of its nature, more testing, and specifically quick check kind of testing. So what it does is for every price level that comes into the system, and price level is essentially just a price. So if somebody wanted a certain price and there was no order of that price, there's a new process that is being created for that price level. And every process has bids and asks in an ordered set ETS table. So what happens is when a new order comes in, a new price level process is being created if there was no price level process that was matching to that. And this order is shipped off to this process. If there was a process that was either matching this price level or was close enough, it was basically, it could have been lesser than the one that you're trying to put into the system. So if your incoming price level is 100, but there was one that was 90 that was already available, it will automatically ship it off there just to offload this influx of orders, so that the process that receives it but sees that it actually doesn't match, it tries to find the next process in the line of processes and ships it off to that process, so that process can deal with it. This way we actually take this load off the inbox process that would process incoming orders and just spread it around the system. And results obviously were quite interesting. So the same number of orders was roughly, I think it was about 7 or 8 seconds, which was much more impressive than 2 minutes. Hopefully it's still valid and there were no mistakes, but we'll see later when we'll start reintegrating this with the products. And surprisingly, it was still 200 lines of code. So it was obviously a little bit more complex in terms of what it did, but size-wise, it was pretty much the same. And another related matter, so there's a protocol called FIX, which is used basically for financial institutions to exchange information about trading-related information. And Their specification is about 700 kilobyte, if I'm not mistaken, XML that describes all kinds of messages that exist in Fix and what kind of responses they can generate, etc. So what we did, and Elixir was actually a huge, important, it was playing a huge and important role in that. It allowed us to automatically, every compile time, take that XML file and create three parts of the library. So one is decoding, so we're just reading a serialized Fix message, and we can create an Elixir representation of what that message means instead of just number, because Fix uses numbers a lot, so all those messages look really cryptic. But once it gets out of decoder, obviously it makes a lot of sense and it's pattern matchable, etc. Encoder, so you can do the reverse operation. And what was really important for us, and it proved to be really, really useful, is we created also automatically generated validating composing functions, so that when you compose a new Fix message, it will tell you that, for example, this kind of attribute does not exist in this message, and similar errors. So if somebody made a typo, for example, and it didn't go there as an atom, for example, it wouldn't basically compile, because the macro that we were using, it would generate code that would stop your compilation process, and it will tell you, well, I don't know about this key, it's just it doesn't exist or is not allowed in this message. So this way we could have, and actually did detect a lot of mistakes early on. So that was very useful. Moving on.
So on the thing we were just talking about with the validating of the attributes on the messages, now that records are, now that maps are into the 17 and Elixir has records and structs, would you potentially change that to use, sorry, not records, maps and structs, would you potentially change that to use a struct so it doesn't code the type thing, and you can also see that it'll likely blow up if you try to update a key that doesn't exist?
Good question. I would double check that again, but one of the reasons why we, for example, didn't do records for this in this existing implementation is there's way too many messages there. I think we were trying to create like hundreds of records, and that was just making the whole compile process taking like 5 minutes, which was really not something that you would expect out of a compilation process. It really depends. So if eventually creating hundreds of modules will be cheap, then creating that many structs would be affordable. Otherwise, I would probably still employ the same practice of generating very, very little modules, maybe one or two, and then basically just generating tons of code that validates every single possible variation. It's going to generate big beam files, but that really is not that important. It will quickly detect that something is wrong. And it also allows you for a much, much more granular validation process. So if later on you want to validate more stuff, and obviously we don't validate everything, just the most obvious errors for now, then you can just start adding more and more checks, like, for example, is that the right type that I'm using for a certain attribute? Like, it should be integer, but I'm passing a string. Probably something is wrong, right? Stuff like that. Does that answer your question? Cool. So moving on to the general architecture. We actually already have a second version of our platform. So the first version of our platform, we tried to do it a really distributed platform with a lot of communication between components. But after about 3 months or so, we realized that about 80% of our code is not about the business logic, but it's actually about communicating between components. And that was just getting messier and messier and messier with every day. So we had to put a stop to that. And throughout pretty much, well, 95 to 100% of code. Like there's very little left in the second version from the first one. And after a lot of consultation with people who were creating financial systems for a living for a number of years, we decided to go with the so-called Big Rocket server model, where we have a beefy box that has our application server. It also has a database on it that is replicated on a standby. So this way we always know that if database is not available, it's not a networking problem. It's actually something that's going on our server. And it actually also helps us with consistency, because with financial transactions, consistency is the key. You can't really be eventually consistent with money. you have to be really consistent. And then again, due to our business model where we would have separate exchanges in different countries, we are still not expecting a huge amount of traffic coming at each one of those. So if we had one exchange for everybody in the world, that scaling would be a big issue. But when you're targeting regions and countries, you actually don't have that problem. So it's a problem that might come in some countries, and we can mitigate it in one or another way. But until that, why do we need to solve that problem? We can just have one piece that works really well. And so far, this approach has paid off in terms of development time and simplicity. It's fairly straightforward. And what do we do there is quite simple. Our front-end application is completely disconnected from the back-end in terms of business logic. So the server doesn't really know anything about how the front-end application will work. And it just provides WebSocket, or in this case, actually SockJS-based API. It's sort of like streaming APIs. So some calls will only return one result, and they will never send anything else. But others will just continue streaming data into the application, so we can provide a really, really responsive kind of UI that will always update user on what's going on with his account, with his trades, etc. So he doesn't need to reload a page or wait for something. It's very instantaneous in that way. And in between the server and the front end, we also have a very simple Erlang application that is essentially a proxy. It handles the SockJS part of the communication and opens up simple socket connections between itself and the application server on another physical box, which means we're sort of gapping the connectivity between the front end and the back end, so we're isolating it. And it's partly a security measure and partly a measure in protecting the system from the overload. So for example, some clients start sending too much data in, we have a way to start dropping packets early on before hitting the application server. And we can start introducing more of those proxy servers in front of us and start routing to them as well from Amazon ELBs, the load balancers. So this way we can move away this sort of abusing traffic that has happened to our system. So this way, the application server is almost never affected by this kind of attacks. Any questions so far? Is it too fast, too slow? Is it good? Okay. Another completely unrelated topic. Where was it? Yeah, so the last item there was everything in our system is Dockerized. Anybody here who's not familiar with Docker at all? Okay, so Docker, are you familiar with Linux containers? So basically Docker is just sort of a convenience tool for Linux containers and union file systems. So I'll explain why did we actually use that. So around September, October last year, we realized we spent a lot of time trying to get every development machine in sync with each other. Versions of Postgres, especially we were using some very latest versions of PostgreSQL, such as improved JSON data type, etc. So doing that was really complicated, and some of us have Linux machines, some of us have Mac machines. So that was a very big difficulty, and we were spending probably up to 30% of our time just dealing with those little subtle problems that we're able to get rid of. And we tried out Docker and Vagrant. So basically, if somebody's not familiar with Vagrant, it's a tool that allows you to use either VMware or VirtualBox to create a machine and quickly provision some stuff on it and give you an easy access to SSH into it, and also mount your host file system, or rather parts of your host file system, into that new box, so that, for example, you can continue developing on your own machine, and that data will always be in sync with that Linux installation on the virtual machine, so that you write in your editor on Mac OS, for example, but then you run everything on Linux in the virtual machine. And as I said there, don't even try using VirtualBox. It's way too slow, so you'll hate yourself. Go for VMware. It's not very expensive. It's worth it. except that don't expect it to be flawless either. Vagrant will fail once in a while, and you will have very frustrating problems with it sometimes, but generally it works. So it's a pretty good combo. And we also take those Docker containers into our production so that we can also keep upgrading our stuff in this fashion so that every container is an isolated system in a way. However, there's a couple of things that I do want to mention about Docker, especially with the fact that it's still pre-1.0. There are a couple of issues with it. So fundamentally, one of the strongest things about Docker, those isolated containers, are also its own weakness. So every time you're creating a new container, or rather image, and have to deploy it, or for example, you build it every time in your continuous integration cycle, and you want your developers to pull back in, expect to transport really large files. It's not common to have to transport, say, 2 gigabytes, 3 gigabytes at a time, which if you're deploying and your CI is in the cloud, for example, in Amazon, wouldn't be a problem. But if you're in regular Office connection, it's a little bit of a problem. It's not too bad, but you would expect to have a couple of coffees until you're done. So just know that it's a thing and it's just a reality. We still don't know what would be the best solution to this. Still researching, but there's no good answer just yet. The other one is if you will continue using registry, and we actually still use registry, it's a nightmare. Basically, there's no way to ensure that you'll always get a consistent result. So sometimes it will just randomly fail downloading some parts of your image, and it will just say 404 for some reason. But then you restart it and it works. So these things are probably terribly broken for now, but we've been talking to Docker maintainers, and they've been saying that they have plans how to improve this and how to even separate it from their central daemon approach so that every download is a separate process. It's kind of isolated from the entire server. So that probably will be fixed maybe around 1.0 or sometime later. But for now, it is a little bit of a nightmare. On the other hand, I wouldn't say it doesn't work. It's just something you need to be aware that you'll be frustrated at times, and especially when it comes to automatic deployments of any kind, say Chef or anything else, you would have to, like if you're pulling images, expect them to fail sometimes at least. So things like this. And another thing is a mistake that we have made but planning to fix is don't even try to build a new image every time you build your new Erlang release. It's just too slow, and you're building a really, really big image that contains parts of Linux, Erlang, etc., and you have to ship it all the time. What we're thinking of is basically build one production image and have a mountable volume there where we'll put our updated code of our application and restart it with it. So that was a big mistake, I guess. It just slows down our iterative process. Like when we want to redeploy, it just creates a lot of friction there. So there's that about Docker. Other things. So it's just observations about having to live in this environment when your AngularJS is not even released yet. So when you're using a release candidate or even beta, Elixir is almost always master. Erlang is the latest one. PostgreSQL also beta 1 or beta 2. What do you do with it? So what we've figured out so far is, even though using head versions of certain libraries is an enemy, but like that proverb says, you have to hold it closer than your friends. And if you actually embrace head, if you keep upgrading, it actually will eventually be a much better experience for yourself. And at the same time, you're also contributing a lot, helping authors of those libraries or languages or whatever that is, fixing bugs before they actually release, not after they release. And the practices that we have so far came up with is don't delay upgrading, say, Elixir or Postgres or whatever you're using until it's too late, because otherwise you'll have to go through a lot of upgrade pain and it's not worth it. But don't do that before the release. So ship first and then continue upgrading. Because obviously our experience is upgrading right before the release is slowing down the shipping date by quite a lot. And it's always with new stuff, expect to write a lot of your own libraries or patches or whatever it takes. We had to write probably about 20 libraries in the past year. Most, or if not all of them, are on GitHub. And it's just part of the reality. There's no way around it, I guess. That's just it. And in our experience so far, what we've had is we went from 0.9 for dev, which is pretty much 9.3, to 0.12.0, which is not the latest anymore, but it's close enough. And it's about 300 lines of just worth of change log that we have went through so far. I think it's quite interesting. And after we ship our product, which is coming really, really soon, we'll go for R17, 0.13, and we'll be working on moving on to maps and all this kind of stuff, so that we're not left behind for a year or two before we can actually upgrade to that. Another topic. The interesting implication of this kind of development cycle is that it actually inspires you to go out and experiment and do the right thing and create interesting software on the way of creating your main software. And I'll just give a couple examples of what we have created in the past year. So here's ExLogger, and what we wanted to create is a better version of Lagger. We've been using Lagger before, but there was a couple of issues with it. So, and obviously Lagger wasn't quite well suited for Elixir, because it was formatting everything in Erlang terms. And that was actually the first point why we decided to start experimenting with our own library. The reason was that if you log with Lagger, every time you log, your process is suspended until the data that you put into the message is rendered. So this way, you're slowing down your application essentially. And if your data is more or less complex, then you're in trouble. You're essentially reducing the performance of your system till you can log. So the main idea behind ExLogger was don't do anything with the string and the data that is attached to it, just ship it off and continue doing what your process is doing. And the way it looks like, so you would have, so L is just an alias for ExLogger, just for simplicity. What you would have a message that has its own string interpolation syntax. So unlike in standard Elixir, where you have hash, then curly brackets, and name of the variable, here it's $. So standard Erlang parser does not see that as a string interpolation primitive. So it just passes that as a string. And then you pass a keyword list, which has user, size of the t-shirt, etc., whatever you want to pass. And what's also interesting about this, you can actually have more complex structures passed into variable values. Like you can have a user that is also another keyword list with other keys in there. So you can say user.name, for example. So it actually understands that and tries to go into deeply into the structure. So what is important with this kind of approach is that, first of all, we don't render this string while you're logging, but another implication there is you don't have to render every variable that you pass. So there's a lot of auxiliary variables that you do want to see in some login system like Splunk, but you don't want them rendered ever. So for example, time or username in the session, etc., right? You don't want to see that in the message every time you're just reading the log. It is important to have that data later on for future analysis, but you don't want to see it all the time. And this approach does allow you to do just that. And one of the most important things about our approach in there, I think that will actually be configurable default attributes. And what that means, imagine you have a module that deals with, let's say, HTTP calls that come into your system, and you have some sort of session associated with every request. So you would know what username you're dealing with and other information related to that session. So instead of passing all this data to every login call that you have, when you're including the use of ExLogger into every module, you can specify coded code, so the code that will be inserted into your login call, that will be used to populate default attributes such as username or current time, whatever you want to collect with every login operation. And this way, you don't have to go and copy paste these bits everywhere in your code. You just specify them once and control from one single place, and then you just collect this without remembering that that data is even there. And after you use configurable backend, so for example, you can still run an IO backend for login in your system that what you see on the console, but you can also send data to Splunk. We actually open sourced that adapter as well. It's pretty simplistic for now, but it does the job. So you can send off the data, it's formatted into JSON and just shipped off to Splunk. Then you can have really complicated queries and see, for example, what specific user did over some period of time, and involve in certain module in the system. So if you log, for example, a current module where this login operation was called from. So there's a lot of interesting stuff associated with that. And another important aspect of this, you can even create backends that don't log anything, but can be used for things like tracing. So these backends will still continue receiving not just strings, but objects containing actual data, and they can trigger certain behaviors, like tracing behaviors, when they receive them. So you don't need ExLogger to have that functionality embedded. Instead of that, you can implement whatever you want. So it's not going to be a match spec, which is probably a good thing, because match specs are incredibly difficult to write. You just write a piece of code that in parallel processes whatever is happening and analyzes or sends alerts of any kind that are essential for your system. So that's pretty much about it about ExLogger. Another one is Hypnotoad. So Hypnotoad is our take on orchestrating servers. And there was a couple of motivations why I basically sacrificed one of my weekends in the office. So I was really furiously unhappy with whatever is available in the market, such as Chef, Puppet, Ansible, SaltStack. I've tried them all, and I just wasn't happy for one or another reason. The list of reasons is too long, probably. But I collected a list of wants and wishes, what I really wanted to see there, and I was inspired by some unpopular but interesting small tools that were trying to solve the same problem. And I really didn't have a lot of time, and I was really disappointed that none of those systems are really actively using Erlang. So what Hypnotoad does is, it's a very simple tool. It opens SSH connections to multiple hosts that you're working with, and keeps them open. So you don't need to reconnect all the time, spend time on that, negotiating the keys. And lets you write modules in a very simple form. You write two callbacks. First one is a test callback, the other one is a run callback. So test tests certain precondition or just a condition on the server. And if it fails, then we run the run callback, and it does something to the server. And then we run test again. And if it succeeds, then everything was successful. If it doesn't, then we say, well, that was a failure. But if the first test succeeds, we never run anything else. We assume everything was already deployed, so we just don't do anything anymore. And that obviously reduces a lot of overhead of dealing with this kind of operations. It also resolves dependencies between modules, so module can depend on other modules with certain attributes. So, for example, certain operation might require a deployment of a file, so you can just say it requires that module with the file name and where to take the content from. Very convenient. And it runs it all in parallel and reports on everything instantaneously. And how it does it is this. So Hypnotoad actually doesn't have a CLI interface at all, unlike all other tools. The only way to really work with it is through a web interface. So what it does has a WebSocket server embedded into your tool that you don't run on the server, but just run on your workstation. And it has this server. And here you can see it has those modules, what attributes were passed into those modules, what host this particular instance of a module working with, what the status could be. Success could be running, could be pending. And you can see a log button. It's a toggle button on the right which when you click and you see an example here, it will open a shell session that is working with that host at this moment, and you will see in real time what it's doing there. So for example, if it's been running for too long, you can just open it up and see what is happening there. Maybe it's just too many packages that it's installing and it's all right. But maybe it's stuck with something because you made a mistake somewhere. So it allows you to be sort of non-linear with the process of deployment, but just see what's happening by just going through it. And we found it quite convenient so far because it really provides a very easily understandable interface to a human, as opposed to machines, really. And it really allows to debug really well. So to summarize the features that it has, it doesn't require any servers to be installed on the target host. All you need to have there is SSHD. As long as you have it running, you're good. It's highly concurrent, so especially if you modify your server's max sessions attribute in the SSHD config, it will basically multiplex SSH connections to any extent you want. So by default, it does up to 10 connections because this seems to be the standard number in SSHD by default. So it allows 10 sessions at a time. So we'll run that in parallel. Like I said, it has first-class web UI embedded. It has built-in lock management, so you can lock out certain operations that you don't want to happen in parallel, say on one host, on a group of hosts, anything you really want to do with it. Another really interesting feature that comes with it, it allows you to do dynamic SSH port forwarding. So imagine you've deployed your server to one of the hosts, and you want to run some HTTP operation against it. So instead of installing, say, curl or wget on that machine and trying to do something that way, you just have one command that would forward one of your local ports to the port over SSH connection. You work with that HTTP server using one of the Erlang HTTP libraries, do whatever you need to do with it, parse it, and then just close that port forwarding. You're done. So you don't need any extra tools. It allows you to play with any service that you deploy on your remote hosts very easily. And obviously the nice thing that it lets you write your scenarios in Elixir. So you can use the power of both Elixir and Erlang to achieve the results. So what enabled this tool? Yeah, fine. Okay, perfect. The great thing is that Erlang OTP actually has SSH application right in the distribution. It's not perfect, but it's there. It does the job more or less well, and I'll tell a little bit more about this in 1 minute. gprog is a fantastic process registry tool. I've been using it for many years and couldn't be happier, probably. Cowboy, probably everybody knows Cowboy. And other enablers are really simple. It's Elixir and a couple of sleepless nights, and a cute misunderstanding of what NIH means. And some interesting discoveries along with that. So Erlang SSH library, like if you ever plan to use it, just before anybody fixes this, you have to know that there's one little interesting thing about it. When you tell it to close a channel, don't actually expect it to be closed right away, because it just sends a message to the server and just washes its hands. But in fact, it will take some time to close that channel. And if you try to exhaust the number of sessions that are using, which is exactly what this tool is doing, you'll have some really interesting behaviors. Basically, you know that you closed the connection, but it doesn't look like you closed it. And when you debug it manually, you will never encounter this bug because you type way less faster than SSH closes connections. But in reality, this will happen. If you ever run into this, I'll probably save you at least 4 to 6 hours of debugging. And apparently, at least at the time I was writing this chunk of slides back a couple months ago, there was no good generic mutex semaphore library for Erlang, which is actually surprising. Right? It's a very useful bit of functionality for any system, especially distributed system or server system. But there was no good way to do this in a very generalized fashion, and we needed it, so we just implemented simple bits here and there. But if you want to, for example, try out Elixir or something, that's probably a really good candidate to play with, and it's actually, I think it's very instrumental for learning Elixir, and it's very instrumental for whoever will be using Elixir or Erlang, to that matter. And well, the other one is basically insane things are possible indeed. Just you have to be crazy enough. So yeah, here I'm supposed to hydrate myself, but there's no water. Bottom line, was it necessary to get crazy about these things and actually use all of those cutting edge technologies to get to, to meet our ends? I guess that's the answer. It's both yes or no. There's no way to really verify that because we can't really travel back in time and try the other approach. I think it was worth it. I wouldn't say it was necessary. I think it was worth it. What's next? Oh yeah, so if you want to be part of this insanity, we are hiring right now, in time, and questions and answers. Anything?
What's AMA?
Huh?
What is AMA?
Ask me anything. Anything?
What were you needing semaphores for?
Huh?
What were you needing semaphores for?
It was related actually to controlling the number of sessions, I think, because I needed to get to a certain number of sessions that I'm using at the same time. I think it's somewhere there. Like I don't remember details right now, but I needed to lock out at a certain number, so something like that. So basically, set it at 10 and go down to 0, and that's when everything's locked out, kind of thing. So I needed a more generic approach to this because I had to write some piece of code, and it took some time to debug it because obviously I made a couple of mistakes there. But if there was like a well-tested, quick-checked library that does, various ways to various primitives for locking and semaphoring certain changes, that would be really great. It just wasn't there. Maybe it is already there, but as of November, when that part of the presentation was written, there was nothing. So.
I think Ulf might have written something, and I think he released it in October.
So roughly the same time.
Yeah, it's called Locks, I think.
I think I looked at it, but I think it was solving slightly different problems. So it wasn't solving my problem, or it wasn't generic enough to support my problems. So I remember seeing it. I don't remember details about it, but yeah. Any other questions?
Are you handling like releases in any particular way, or when you deploy, are you just basically setting up the code, having an account under the Docker file?
Yeah. So the question is, are we using Erlang releases, right? Actually, we are. So we're using a tool called RelX, not to be confused with RelX. So there's like extra E before X. It's an Elixir tool that builds releases. It's not perfect, but it works so far, and I've talked to other people in the Elixir community. They're also using it, so apparently we are not the only ones using that one. So the only thing that I actually did mention a couple of slides ago is if you use Erlang releases and Docker, which seems to be quite a popular tool these days, do not build a new Docker image every time you build an Erlang release. That was a painful mistake. Anything else? I guess nothing then.
Thank you, Yurii.